Hi, grade 11s. Today we'll continue the sine functions, continuing from part 1, now in part 2. So remember that we drew or sketched the graphs y is equal to sine x, which looked like this, and the transformation of these graphs, where the graphs was moved up or down, meaning vertically shifted up or vertically shifted down. We also stretched the graph. It's vertical stretch, or we compressed the graph. Now today we'll be looking at how do we transform the graph about the x-axis. We can move it left or right, or we can press it, or we can stretch it, or we can also reflect it. So I've extended this graph of ours as y is equal to sine x. We started at 0 at a previous lesson. Now I've continued with the graph of mine to the negative values of x, because it's a wave, is continuous like that. Now let's see how they can ask you questions. Here's an example. Say, on this same system of x's, sketch the graph of f of x equals sine of x minus 45. You will recall from algebra that when you have brackets like that, it means that the graph must shift. So how do we shift? It's a horizontal shift. So we solve for x here. So we've got x minus 45 degrees equals 0. So x is equal to 45 degrees. Which means that this graph of ours has shifted 45 degrees to the right. Meaning each and every point that I've put on the graph will be shifted 45 degrees to the right. If I shift this point 45 degrees, it will be there. If I shift that 45 degrees to the right, it will be there. That one 45 to the right, it will be there. That one will be there. This will be there. That turning point will be up there. This will be there. And this will be there. And that one will be out of 360. So it will be somewhere there. Now, if I were to join these points like this, you can see what's happening with the graph. It has shifted vertically or horizontally, 45 degrees to the right. So if I'm going up there, you see it's going out of the thing. Now, because this is a wave, it means that we could have continued to there. However, they don't ask you to draw as outside that. So maybe they can say minus 360 to 360, means that we'll have to cut your graph over there, means that we'll have to cut it here. So this piece here won't be requested. Now here's a question, says here, describe the type of transformation that happened to the graph. You can see that the red graph, it's as if that it's been shifted to the right. So this point is shifted to the right. All points are shifting to the right. So therefore we say that the transformation that is a horizontal shift of 45 degrees to the right. Let's look at another example. Now note, remember that you always still need to work out the points here and give us the coordinate. So the coordinate here will be 135 degrees is to 1. So the coordinates here now will be 315 degrees is to minus 1. This one will be now minus 45 degrees is to minus 1. And this one over here will be minus 225 degrees is to 1. So this one here will be minus 360 degrees is to something. You'll have to like solve it. Okay, let's look at another example. It says on the same axis of sketch the graph of f of x is sine 2x. Now this is sine 2x. Note that sine 2x is not the same as saying f of x is equal to 2 sine x. The previous lesson we had 2 over here. We're multiplying the whole of sine by 2, meaning we're affecting the y value. Now we are multiplying the x by 2. We are affecting the x value. So what are we doing here? This means that we are increasing the frequency by 2, meaning that in this space here, if I've got one wave here, I must have two graphs here, meaning that each and every x value, because I'm affecting the x value, I must divide by 2. Each and x value, I must divide by 2. Divide each and x value by 2. So if I were to divide the x value here by 2, I will get 180 degrees over there. If I divide now this 180 degrees by 2 from the original point, I will have a point over here. Now, if I divide this one by 2, I'll have a point over there. Now, if I were to divide this one by 2, I will have this point over here. Now, this is a small version of what you have. Let's just see what shape we get. We get here, this part here going thing like that. To see that now I've got the smaller part of this, but I've got to continue with this thing here. So which means if I were to continue, I will have this thing here going up and then to come down and then until I stop there. So how do I do that? So I'll come down there and then all the way to there. Now you can see now I've got two waves here. Because I've got two, I'm doubling the wave. Double the wave. So here I will also do the same thing. I will double the wave. So which means that here to have two waves, so it means that I'll have to go up somewhere there. So it will go up there and then I will cut there and then turn down there and then it will go up there and then it will go up to that one and turn there and then turn, do something like that. Again, I've got double. I've got this one wave, another wave. So I've doubled them. Meaning that if I've got 3, I'll triple the red thing here. Okay? Now here's a question. The question is, what is the period of the graph of f? This new graph that we've thrown. The period of this thing. So let's write here the period. The easy way of finding the period is just taking 360 degrees. You divide by that number which is there. We divide by 2 and the answer is 180 degrees. Another way of looking at it is just work out how long is one wave. Because here I've got now 4. How long is one? From 0 to 180, that's 180 degrees. Alright? Then describe the type of transformation. You can see here I've compressed the graph now. So it's a compression. It's a horizontal compression. So say here horizontal compression. But how? With a scale factor of 2. Okay, let's look at another one. Here's another example. On the same axis, now sketch the graph of f of x equals sine of minus x. Now this is a negative x. Recall from the previous one again that previously we had f of x equals negative sine x. This one we said we're multiplying the y values by a negative, but in this one we are multiplying the x values by negative 1. So if I were to multiply this x value by negative 1, it will therefore mean that I'll have a new point here which is 90 minus 90 degrees is to 1. So the point will be over there. So if I were to multiply this one by negative 1, the x value by negative 1, I'll have a point which is 270 is to 1. So the point will be up there. If I were to take another point, say I take this one here, this is 360 degrees is to 0. If I multiply this by negative 1, I'll have a point over there. Now, if I multiply this one by negative 1, I'll have a point over there. If I multiply this one by negative 1, the x value by negative 1, I'll have a point over here. If I multiply this x value by negative 1, I get negative 270 is to minus 1. I've got a point over there. I just jumped around here to make things easier. But if you look at the points now that we have, we've got this point here joining that, and then going like that, and doing that, and that, and that, and that going there. So what we've done here, we just reflected the graph about the x-axis. So when you multiply x by negative sign, you are reflecting it about the x-axis. However, there's something that they said here. They said x must start from negative 90 to 90 degrees, meaning they want our graph to start from negative 90 to 90 degrees, meaning that the only part that they are interested in is this part here. So this is what the examiners do. They say sometimes draw the graph, but then they give you the restriction, meaning all of this part you don't need. You can erase it, remove it because they don't want it. You remove the thing that they don't want. You remove it, then you've got a correct graph. But remember that the coordinates, like this one, they will need what are the coordinates. Now it's 90 degrees is 2 minus 1. That point over there, it's minus 90 degrees is to 1 over there. Now describe the type of transformation. As we said, you can see that this piece is like it's been reflected about the y-axis. So we can say this is a reflection about the y-axis. Okay, let's look at the last one. Sometimes they can say, describe the transformation of y equals f at x to form the graph g at x equals negative half times f of x plus 10 degrees plus 1. In this case, they don't want you to draw. They want to see if you understand. How can I change this graph to this? You can see that this graph of f has been multiplied by negative half. What did we say in the previous lesson? If I multiply f by coefficient, is either I'm vertical stretching it or compression. Because this is half, I'm compressing, I'm making it small. So it's a compression, a vertical compression. Can you write that? Vertical compression by scale factor of a half. And then there's a minus there, meaning now I've reflected about the x-axis. All right, we also had a reflection about the x-axis. The next thing, there is plus 10. You solve for x. When you solve for x, you get x plus 10 equals 0, and then x is minus 10, meaning that the graph shifted 10 degrees to the left. So a horizontal shift of 10 degrees to the left. Then there is a plus 1. Now what happened? The graph is moved 1 unit up. So it's a vertical shift of 1 unit up. Okay? Let's see what you can do, guys, when you're given some examples. From your textbooks, Yavula textbooks, chapter 5, which says functions, 5.5, you do sine functions, exercise 5.21, exercise 5.22, and exercise 5.23. That is as easy as that. Good luck.